Today we are going to talk about lens maker's formula. This lens maker's formula is widely used by the opticians to manufacture the lenses of any desired focal length. Here, it's a derivation. This derivation question will be often asked in the examination in essay question. So be thorough with the derivation. Here look at the diagram. First we have to draw the ray diagram. You should know how to draw the ray diagram. I have drawn one thin lens here. So in the thin lens, two surfaces are there. Two curved surfaces are there, 1 and 2. Here I have drawn the principal axis. Here this is the geometrical center of the lens, that is called pole. I have chosen a point O on the principal axis on which I have kept the object. From the object, the light ray, it is going to travel. So here the distance between the pole and the object should be always taken as object distance, that is mentioned by the letter U. So here I am going to draw the ray from the principal axis. It is going to incident on the first surface. Look at that. This is the incident ray. This incident ray is made to incident on the first surface. After getting refracted, the incident ray gets refracted. No, the refracted ray, it is going to travel very farther from the lens. I am using the same yellow line. Look at that. This is the refracted ray. This is the ray, it incident on the first surface. After getting refracted, the ray, it falls on the principal axis on the other side. So this is the refracted ray. The location can be called as, what is this? P. Here I dash is there. So the in-between distance Pi dash can be called as B dash. Very important. It is very far from the pole. Are you clear? Now, if the same ray, after getting refracted, it falls here. If the same ray, if it happens to fall on the second surface, what will happen? The same ray will get refracted, and that one may, with respect to the second surface, I am going to draw the refracted ray. Look at that. Here I am going to draw the refracted ray for the second surface. If it gets refracted on the second surface, what will happen? The ray gets refracted and it is incident on the principal axis exactly at I. Are you clear? Now this distance can be taken as, with respect to the second surface, the ray get refracted. So this distance between the image I and P can be taken as V. Know the difference between V dash and V. V dash is the image distance with respect to the surface 1. V is the image distance with respect to the surface 2. Note the difference. This is the very important one. I have written everything here clearly. This is object distance. This is the image distance with respect to the surface, curved surface 1. This is the image distance with respect to the surface 2. Okay. These are all the assumptions which are very much required for further derivation. Now we are going to start the derivation of lens maker's formula. Just in front of the lens, the refractive index is N1. This portion is occupied by air. There also this portion is occupied by air. Therefore, both the two refractive index are same. This lens portion is made up of glass. Therefore, its refractive index must be taken as N2. So, with respect to the first surface, when light ray travels through the first surface, it travels from N2 refractive index medium to N1 refractive index medium to N2 refractive index medium. There the object distance is U. And then with respect to the surface 1, the image is formed here. Therefore, the image distance is V is equal to V dash. Are you clear? When the light ray travels from, it passes through the second surface, that is from N2 refractive index medium to N1 refractive index medium, by the time the object distance U must be taken as V dash, because this image, it acts as the object for the second surface. Again I am repeating, this image I dash, this one acts as the object for the second surface. Therefore U must be taken as V dash. And the corresponding image distance is V is equal to V. So this is the image for the second surface. And then I have written the This is the equation which was already derived in the last class. This is called as refraction that is related to the first spherical surface, single spherical surface. This is an equation called refraction at a single spherical surface. So we are going to use this equation for further derivation. Very important equation. We have to recall it. Now I am going to use this equation for the first surface. Are you clear? So I will start the derivation here. For the first surface, I am going to use the equation of refraction at a single spherical surface. What is N2 second medium? With respect to the first surface, second medium is N2. Therefore, instead of N2, we can write N2. Here V is there, image distance. That image distance is nothing but V dash minus N1. What is N1? First medium, N1 divided by U. Object distance is U. No change at all. As usual, we can write N2 minus N1 whole divided by, here R is nothing but radius of curvature. For the first surface, the radius of curvature can be taken as R1. Therefore, this is called equation number 1. Now, let us see the second surface. I am going to write the equation for the second surface. For the second surface, curved surface, I am going to write the equation. How will you write? N2 means second medium. Second medium is N1 here. Therefore, N1 divided by V means image distance. Here image distance is V. Okay. Minus, and then N1. N1 means first medium. First medium is N2 here. N2 divided by, and then U. What is the U? This is called object distance. Object distance must be taken as V dash. Okay. Again, N2, first medium must be taken. Here, first medium is N2 means second medium. Second medium is N1. Therefore, N1 minus N2 divided by radius of curvature is R2. Therefore, R2 can be written. What is R2? Radius of curvature of the second surface. So, we have written two equations. Very carefully this equation must be written. Now, first equation and second equation, both of them must be added. Okay. After adding, how will you get? Add them in proper form. N2 divided by V dash. N2 divided by V dash minus N1 divided by U, and then plus, add this one, N1 divided by V minus N2 divided by V dash is equal to, here substitute, N2 minus N1 divided by R1 plus, this one must be written, N1 minus N2 divided by R2. So in this form we can write. So here two similar factors are there with different sign, opposite sign. Therefore, both of them can be cancelled, and this one can be written as N1 divided by V minus N1 divided by U, which is equal to, here N2 minus N1 divided by R1 plus, here you simply change the sign. If the sign is changed, you will get minus sign. If it is simply altered, you will get minus sign. Therefore, we can bring these two factors similar. So here N1 minus N2 is there, here N2 minus N1 is there. Just to interchange this, I am changing the sign. Minus of N2 minus N1 divided by R2 can be written. Next, what is the next step? Here, the next one is N1 is a common factor. N1 can be written N1 can be written outside the bracket. N1, 1 minus V divided by 1 by U is equal to, this is the common factor here, N2 minus N1, this is the common factor here. The rest of the factors are 1 minus 1 by R1 divided by 1 by R2 can be written. Are you clear? So this is the step. Okay. Here this N1 can be brought down here. So will you write 1 divided by V minus 1 by U, which is equal to N2 minus N1. This N1 can be cross multiplied. Therefore this one becomes N1. So the remaining factor is 1 by R1 minus 1 by R2. So like that we can write. Okay. Here I am going to continue the rest of the equation here. Previously I have written 1 by V minus 1 by U is equal to N2 minus N1 divided by N1, 1 by R1 minus 1 by R2 as the previous equation. Here we can do some modification here. 1 by V minus 1 by U is equal to, this one can be, that could be split, N2 divided by N1 minus N1 divided by N1 can be written as 1. Okay, if this portion, this one becomes 1. So the equation, it is edited like this: 1 by R1 minus 1 by R2 is the next format. Now we have to assume that here the object is kept at infinity. When the object is kept at infinity, U will become infinity, and the light will be, that object will be focused exactly at the principal focus. Therefore the image distance becomes F, V becomes F, that is focal length. So V can be replaced by F. 1 by F, 1 by infinity can be written, and then few more assumptions can be written. Here N2, what is N2 here? N2 is the glass medium, that can be simply written as N, and the air medium refractive index can be taken as 1. Therefore instead of N2 substitute N, instead of N1 substitute 1. Therefore second medium can be simply written as N, and first medium, air medium refractive index, can be written as 1. Therefore we can write the equation, it looks like the next format. Okay, 1 by R1 minus 1 by R2. So in this format the final equation it is derived. 1 by infinity, that one becomes 0. So therefore 1 by F, finally we will get 1 by F, which is equal to N minus 1, and the rest of the part of the equation is 1 by R1 divided by 1 by R2. This particular equation is called as Len'S formula. What is this? Len'S formula, very important equation. Often this question will be. Finally we are going to derive the expression for Len'S equation. Here this is also another important equation. This is one of the steps which we have already derived. 1 by V minus 1 by U is equal to N2 divided by N1 minus 1. In bracket 1 by R1 minus 1 by R2 was already derived. Here when the object is kept at infinity, what will happen? The image will be kept exactly on the principal focus. Therefore the image distance will become F. So instead of V substitute F, instead of U substitute infinity. 1 by infinity is equal to 0. Therefore 1 by V, this one becomes 1 by F. Here we have made the change only in the LHS part. There is no change in the RHS part. So in both the two equations, just compare. So in both 1 and 2, the RHS parts are equal. Therefore in LHS part, you just compare. Finally we can write 1 by F is equal to 1 by V minus 1 by U. This is the equation which is called as Len'S equation. So this equation, Len'S equation, that connects, that relates the focal length, object distance and image distance. By using this simple Len'S equation, we are able to do a lot of problems. By knowing any two values, we are able to calculate the unknown one. By knowing V and U, we are able to calculate F, or by knowing the value of F and V, we are able to calculate U. By knowing F and U, we are able to calculate the which one? Image distance also. So this equation is called Len'S equation. In the examination, both Len'S